Let me just get it pulled up here. Let me see if it's actually... Holy crud, it actually didn't. All right, so I'll do number 2 and number 3. So number 2, first off, when we're solving a quadratic by factoring, we have to get one side equal to what? 0. So I need to subtract one side, or inverse operations really, because you'll subtract the 2x, add the 15. Remember, because we don't want to touch the x squared because we want that to remain positive. So the only time you would subtract an x squared over or add it or whatever is if the x squared was initially negative. All right, so that goes away. We should get 8x squared minus 2x plus or minus 3 is equal to 0. Now, when you're factoring, what's the first thing you should always look for? A GCF. Good. Do I have one here? No. So I go straight into what method? Big X, AC. Good. So if I do big X, what goes on top? Negative 24. What goes on the bottom? Negative 2. So what are two factors in negative 24 that add to negative 2? Negative 6, positive 4. All right. Now, Now, we can then break apart your negative 2x. And remember, it doesn't matter the order that you put your x values in. You should get the same answer either way. So I'm just going to write it from left to right that I have here. So I have 8x squared minus 6x plus 4x minus 3. Now, I'm going to rewrite this a little bit off to the side just because I ran out of room. Now, from here, what do we do next? Right, we do factoring by grouping. So I'm going to draw my split. I need to find my GCFs of each group. So what's my GCF of the first group? Be 2x. What am I left with? Good. Now, what about the second group? Is there a GCF first off? No. So what would you have to pull out? A 1. So if there's no GCF, what you pull out is a 1. It's not just you leave it blank. You got to pull out that 1. Now, am I crying? No, because my parentheses are the same. So then you bring out your new GCF, which should be a binomial. And what's that GCF? 4x minus 3. They both got that 4x minus 3, so I pull that out. Then what am I left with? 2x plus 1. Now, some of you guys asked me, is this where you stop? What's my answer? No. Why? Right, you're solving. All right, so your entire quiz is on solving, meaning you have to do what next? How? Set both of them equal to 0 and solve the mini equations. So add 3 to both. 4x is equal to positive 3. Divide by 4. X is equal to positive 3/4. The other one, subtract 1. 2x is equal to negative 1. Divide by 2. X is equal to negative 1/2. So x is equal to the set of negative 1/2, positive 3/4. No, I personally just automatically put them in ascending order. So from least to greatest. But honestly, if you put 3/4 first before the negative 1/2, I wouldn't dock you for it. All right. Then number 3. First off, how many terms are there? 2. So what's the only strategy with 2 terms that we have to look for. So first off, is there a GCF? No. So what's the only other strategy with two terms that we can factor by? Difference of squares. So in other words, you're looking for if you have two perfect squares being subtracted from each other. Is that true? Yeah. All right. So remember, this is a squared minus b squared. So my a squared is equal to 9x squared. My b squared is equal to 64. Remember, you then have to find your a and b. How do I find a and b? Take the square root of both. So what's the square root of 9x squared? 3x. The square root of 64? 8. So, now that I got that here, what do I have to do next? So remember, difference of squares. Once you get your a and b, you're going to put in the form a plus b, a minus b. So you're going to add the two terms and then subtract the two terms. So this should be 3x plus 8 times 3x minus 8 is equal to 0. Then you set both of these terms equal to 0 individually. So 3x plus 8 equal to 0. 3x minus 8 equal to 0. Subtract the 8. 3x is equal to negative 8. Divide by 3. X is equal to negative 8 thirds. Add the 8. 3x is equal to 8. Divide by 3. X is equal to 8 thirds. So x is equal to, now you could write it as the set of negative 8 thirds and 8 thirds, but what's a way you could shorthand it? Plus minus 8 thirds. So if you have the same number, but you have the positive version and the negative version, you can just shorthand it as plus minus 8 thirds. Or you could write it as the set negative 8 thirds and 8 thirds. I don't really care, but I'm just saying that you could shorthand it like this if you wanted to. Say that one more time. Number which one? 1? All right. Yep. All right, so this is the last one that I'll do because the others are pretty similar to these three. So, number 1. First off, always look for a GCF first. Is there one? Yeah, what is it? 7x. So if I pull a 7x out and I divide both terms by 7x, what am I left with? X minus 4. Now, this is honestly one of the easiest solving by factoring, but I can't tell you how many people actually get it wrong because they get thrown by this part right here. So remember what I said about GCFs. Numerical ones are the only ones you can ignore. But what GCFs can you not ignore? If it has a what in it? A variable. If it has that variable in it, you got to set it equal to 0. All right, because you're solving for the variable. The only way that you can ignore the GCF when you're solving is if it was this. All right, no x on the outside because then you could just divide it out and then you just get x minus 4 equal to 0. But if you have the x there, you got to set it equal to 0. So 7x equal to 0, x minus 4 equal to 0, solve for x. So you divide by 7, x is equal to 0, add 4, x is equal to 4. So x is equal to the set of 0 and 4. No, but yeah. So guys, this is another one I can do very, very quickly because number 4, it's already factored. So guys, I can't tell you how many people miss these because they get thrown by the fact that it's already factored. They already did the first step for you. They already did the hard part. They factored it. Okay, so guess what your next step is? To find the answer. So you just set all of the factors equal to 0 and solve for x. So x would equal 0, x would equal 3, and x would equal negative 1/5. Yep. So guys, this particular problem, number 4, is actually not a quadratic. It's a cubic function. All right, so it is going to have 3 answers. So you will get thrown that where you're not actually going to always get a quadratic, especially if you're solving by grouping, like you start with a 4 term. So like if you start with like 4 terms, more likely than not, you're going to have 3 answers. So you get 0, 3, and negative 1/5. Yes, sir.
For 6, would you multiply that 3 back, or would you just keep it on?
Or would you equal it to 0 and then you'd have another one?
Okay, so for 6, so let's just leave like this because I'm sure you guys can factor that after you took the 3 out. So you got a GCF of 3. Remember, if you don't have a variable there, you can just divide it out. So divide both sides by 3, and then anything divided by into 0 is 0. So this would be whatever you have in here is equal to 0. And then you just factor like normal. So that's why I said numerical. Yeah. Numerical GCFs, they don't really matter because you just end up dividing it out anyway and it'd still be equal to 0. The only time you have to worry about a GCF is if it contains that X. If it's got an X or another variable in it, you can't touch it. You have to set it equal to 0 and solve. Does that make sense? All right. So we're going to put a pin in that. So I'm going to plan to have the quiz within the last 20 minutes of class, so 9 o'clock. All right. Because it's really short. It's only 5 questions. So I shouldn't expect you guys to take that long. All right. All right. So I want to revisit a little bit of 4.6 from yesterday. So real quick, go ahead and turn back to page 19. So how does everyone feel about finding discriminants? You guys feel pretty good about that? So does anyone need me to do letter D for an example with discriminant? Speak now, forever hold your peace. Yes? Okay. All right. So I'll do this last problem for discriminant just to review. So remember, with a discriminant, you always got to start with the standard form of a quadratic. So this is what you start with. And then you use this formula to find the discriminant. All right, so b squared minus 4ac. Now, a little later, we're going to talk about where that formula comes from because you will kind of see a version of it again, probably tomorrow. All right, but for right now, just trust me, that's the formula for the discriminant. Now, so with letter D, I got to get one side equal to 0. So what do I need to do? So add the 3x to both sides and what? Add the 4 to both sides. So remember, it's just combining like terms. So if there's nothing for it to combine to, you just slap it on at the end. So this would be 4x squared plus 8x plus 4. Now you're probably thinking, oh, if I factor that, I can take out the 4 and everything. You don't need to do that. All right, the discriminant, to find the discriminant, you just use the numbers as they are. You do not need to factor them. In fact, some of these you will not be able to factor. So like that warm-up that I had you guys do today, that was a non-factorable quadratic. All right. So now you then want to label A, B, and C. So that comes from your standard form. So your A is always connected to your x squared, your B is always connected to your x, and your C is always your constant. That doesn't change. All right. So A is always next to your x squared, B is always next to your x, C is your constant. And if you're missing any one of them, you would plug in a what for it? A 0. All right. So what is my A, B, and C here? 4, 8, and 4 in that order. So then I'm going to plug it into B squared minus 4AC. So this would be 8 squared minus 4 times 4 times 4. So what's 8 squared? 64. Now, 4 times 4 times 4 is the same thing as what? 8 squared or 4 cubed. So 64. This would be minus 64. So what's 64 minus 64? 0. So if I were to actually solve this, how many solutions would I have and what type? We would have one real solution. Yes, ma'am.
What we did yesterday,
Mm-hmm.
like up here, we put like 49 plus.
Mm-hmm. So do you see how right here I was multiplying by a negative? That's why it became a plus. All right. Now, the next part, I just want to review the simplifying aspect. So I just want to do like 1 or 2 of each of these problems just to get your brain thinking about simplifying because we're going to be doing that a lot today. Okay. So this was like the very first thing that we learned with this unit. So with simplifying, what do we always got to do first? So when you're simplifying a radical, what do you got to do first? You also got your 1-pager in front of you that I just gave you if you want to reference that. So how do I break it down? What am I looking for? 2 factors where 1 factor is what? A perfect square. All right. So let's say we did 3,200. All right. So 3,200. Just kind of by looking at the number, what do you think one of the factors is going to be? 100 and then 320. All right. So we got a perfect square right there. So let's just go ahead and do the first simplification. So remember, we can rewrite this as 100 times 3,200. So this is the same thing as 100 times the square root of 3,200. And what's the square root of 100? Yes. Nope. Wait. Yeah, you're right. You're right. All right, so what's the square root of 100? 10. So this would be 10 square root 32. However, do you guys think we're done? No, because we got to double check and make sure 32 doesn't have any factors that are perfect squares. Does it? Yeah. So there's 8 and 4, and then what's another one? 16 and 2. Now, you could easily pick 8 and 4, but you would have to simplify again after that. If you, like, my recommendation is try to find the biggest perfect square so you don't have to do the least simplification possible. But if you can't, that's okay. Just find one where there's a perfect square and you may just have to simplify again. All right? So I'm going to pick 16 and 2. So I'm going to leave the 10 on the outside. I'm going to rewrite this as 16 times 2. So that's equal to 10 times the square root of 16 times the square root of 2. So what's the square root of 16? So this is 10 times 4 times the square root of 2. So what's 10 times 4? 40. So this will be 40 square root 2. And since 2 is prime, we can't simplify it anymore, so we're done. So guys, if we wanted to, we could have started up here with 1,602 and just done it in one shot, but it's a really big number. All right. So for that one, if you just recognize that you could take 100 out and you would just have to simplify it again. When in doubt, just find a pair of factors where one of them is a perfect square, take it out, and then just keep going until you can't take out anymore. All right. You don't have to spend an uber amount of time just trying to find that biggest perfect square because it may take a while because 1600 is a big number. All right. All right. Now, simplifying fractions under the radicand. So remember, the radicand is the number underneath the radical. So if you have a fraction in the radicand, remember, you can rewrite this as the square root of 4 over the square root of 25. So what is this in reality? 2 over 5. All right. So if I rewrite this, square root of 98 over the square root of 8. Now, we talked about this. What's the big issue that we have here? Well, it's not just that, but there's something else that's wrong. What's one of the only things? Say it again. Well, we could simplify it first. But before we do that, there's something else that's kind of like bugging me. What's the one thing that we can't have in a denominator? The square root. So there are two ways you can go about this. My recommendation is simplify them both first, because then you can kind of because then you're not dealing with bigger numbers, and then get the radical out of the denominator by rationalizing. So we're going to simplify these both first. So 98, what are some factors of 98? 49 and 2. So I can rewrite this as square root of 49 times the square root of 2. So this would be 7 square root 2. What about 8? So 4 and 2. So 8 can be rewritten as the square root of 4 times the square root of 2. So 2 square root 2. Now, I need to get the radical out of the denominator. So I'm going to rewrite it down here. So, who remembers what I need to do to get the radical out of the denominator?
Square.
So you got to multiply the top and the bottom by what? Not 2. The square root of 2. So whatever the radical is in the denominator, that's what you multiply the top and the bottom by. Now, what happens when you multiply square root of 2 times the square root of 2? What do you get? Well, there's two ways you can write it. You can write it as either 2 times 2 under the radical, so that'd be the square root of 4. Or, remember, if you have 2 square roots with the same number underneath, that's the same thing as squaring it, which would cancel out the square root anyway. So another way you could write it is times 2. But I'm going to write it as the square root of 4 just so you can see it. So what's the square root of 4? 2. So we have 7 times 2 over, what's the square root of 4 is also 2. So this would be 14 over 4, which can simplify down to what? 7 over 2. Now, if we didn't want to get rid of the radicand, another way you could have looked at it is, since you had a square root of 2 in both the top and the bottom, you can also just cancel it out. Okay, any questions on rationalizing the denominator? Do I need to do another example with it? Are you guys pretty solid with it? Okay, I'll do one more example. So, I'm going to do this last one down here. So first off, I got to get the square root of 2 out of the denominator. So what do I need to do? Not by 2, but square root of 2. Multiply the square root of 2 over the square root of 2. So this becomes 8 square root 2, because remember, you can't multiply a number that's not under a radical by a number that's under the radical. And then what's the square root of 2 times the square root of 2? 2. Or you can write it as the square root of 4. Either way. Now, we're not done simplifying, because remember, I can simplify the numbers outside of the radical. What's 8 divided by 2? 4. So this will be 4 square root 2. Any other questions on that? Yeah, I can do one more. Okay, so let's look at the next one. So I'm going to rewrite this as square root of 20 over square root of 7. So I want to simplify the square root of 20 first, because it'll just give me smaller numbers to work with later. All right. So 20, what can I break that down to? 4 and 5. So remember, you want a perfect square. So that's the same thing as the square root of 4 times the square root of 5, or 2 square root 5 over the square root of 7. Now, gotta get that radical out of the bottom. So what do I multiply the top and the bottom by? Not 7, square root of 7. 7 and square root of 7 are two very different numbers. So the denominator becomes 7, but I would now have 2 times the square root of what up top? What's 5 times 7? 35. So I have 2 square root 35 over 7. Now 35, can I break that down into any factors that are perfect squares? No, the only factors of 35 besides itself and 1 is 5 and 7, so we're done. So that would be our answer. Now, if you wanted, you could have multiplied the 7 to the 121st, but that means you would have had like 140, and you would have to deal with bigger numbers for the simplifying. So it's really just whichever one you're comfortable with. You can either get the radical out of the denominator first, or you can simplify, then get the radical out of the denominator. It's whatever you want to do.
So did multiplying the square root of 7 by the square root of 7 give you, like, get rid of the square root?
Because if you think about it, the square root of 7 times the square root of 7 is the same thing as the square root of 7 all squared. And what does the square run do? Yeah, the square cancels out a square root, and vice versa. It's like the same thing as if I said take the square root of 7 squared. Same thing. It would just cancel out. Yep. Because it would be, if I broke this down, it'd be the square root of 4 times the square root of 5. All right. So let's move on to what I wanted to get to today. So that's 4.6. 4.6 was kind of just revisiting stuff we already knew, and the only new part about 4.6 was the discriminant. So now let's move on to 4.7. So this is on page 22. So today we're going to talk about solving by taking square roots. This one you should already be fairly familiar with. You saw this back in Math 1. It's also just, it's one of the easier methods for solving quadratics, but it only works in certain situations. All right. So first off, when we solve quadratics by taking a square root, all right, first off, what's my order of operations? So if I told you order of operations, what do you think immediately? PEMDAS. So remember, when we solve equations, what's actually the order of operations? Well, think about it. How do you solve equations? You're using what? So whenever we solve an equation, so if I asked you to solve 2x plus 1 equals 2. Inverse operations, right. So In reality, instead of doing PEMDAS, we solve by using what? So think about it. If I solve that equation, what do I start with? Moving the 1. So in reality, I started with what? So I would start this by moving the 1. So I get 2x is equal to 1. Then what would I do? Divide. So that follow order of operations? No, but what did it do? It went backwards. All right. So when we solve, we do order of operations backwards. So in other words, we're doing SADMIP. So PEMDAS backwards. You handle, yep. All right. So that's what that means to solve. Instead of doing PEMDAS, you're undoing the order of operations. All right. So that's the same thing that we're going to be doing here. So for example, if I wanted to solve 2x minus 1 equals 31, how do I solve it? What's the first thing I got to get rid of? The minus 1. So how do I get rid of it? Add it. So I get 2x is equal to 32. Then what do? Divide by 2. X is equal to what? 16. Now let's look at if we threw a x squared in there. So what do you think I would do first based off of order of operations or backwards order of operations? So we would add 1 first. We take care of the subtraction first. We get 2x squared is equal to 32. Now, based off of SADMEP, what would you do next? Would you handle the multiplication part or the exponent part? The multiplication. So that would be the what? So what am I multiplying? The 2. So how do I get rid of it? Divide by 2. So x squared is equal to 16. Now, how do I take care of the x squared? Square root. Both sides. So x is equal to what? Not just 4. Guys, what did I say from now on when you take a square root of something, you always got to put in front of it? Plus, minus. Because we don't know for certain if it's the positive version of 4 or the negative version of 4. So get into that habit. If you take a square on the test, yes, not on the quiz. Quiz is just solving by factoring. Yes.
So should we have done plus or minus 16 for the previous equation?
Nope, because it's linear. There's no x squared. You only got to do plus or minus with quadratic. And that's only in certain situations. All right, so like when you're solving by factoring, you're already getting 2 solutions anyway, so you don't have to worry about it. Now, this next one. So think SADMEP. What would you take care of first? The minus 1. So I would add it to both sides. So I have 2 times x minus 3 all squared is equal to 32. Now, still thinking SADMEP, what would you take care of next? We would take care of the multiplication, but you would not distribute. You can't distribute because of this little square right here. So instead, how can I get rid of the 2 instead of distributing it in? Divide it out. So this would be x minus 3 all squared is equal to 16. Now, what do you think I'll deal with next? Take the square root because exponents comes before parentheses in SADMEP. All right. So we can't take care of the 3 yet until we get rid of the square. So this is x minus 3 is equal to plus or minus 4. And then we finish it up by adding 3. Now let me show you how to figure this one out. So that goes away. X is equal to plus or minus 4 plus 3. Now, here's how you deal with this. You're essentially just breaking it off into 2 answers. you would have positive 4 plus 3 and then negative 4 plus 3. And whenever you get for both of those are your two answers. So what's 4 plus 3? What's negative 4 plus 3? Negative 1. So x is equal to the set of negative 1. I don't know why I wrote negative 4, negative 1, and 7. So that's why it's really important to write that plus or minus, because if you don't, you're missing an answer. Because you want all values of x that make the statement true. If you plugged each of these values back in for x in your original, it would equal 31 if you evaluated it. Any questions on that? All right, let's do some more. So your steps for, I want to skip this section because we already kind of went through it. But your steps for solving by taking a square root, you're going to isolate either the x squared or the parentheses that's squared, where it can be any rational number. And you'll do that just by inverse operations. And again, if you're confused of what needs to go first, just think SADMEP. So that's a way that can help you solve any equation whenever you're using inverse operations and you don't know what needs to go first, just think SADMEP. All right. Then you take a square root to remove the power of 2. And then you will have two possible solutions. Typically, it's a positive version and a negative version. So remember, that's where that plus minus comes into play. So whenever you take a square root, whatever you get after you take the square root of both sides, make sure that when you take that square root of a number, you put plus minus in front of it, even if it's just a simplified radical. All right. So in reality, if I took the square root of both sides here, x would be equal to what? Plus or minus 10. If I took the square root of both sides here, x would be equal to what? Plus or minus the square root of 7. And then here, first off, I break down the 20 into 4 and 5. So this would be 4 times the square root of 5. So x would equal plus or minus 2 square root 5. So again, get in the habit of whenever you take a square root from here on out, putting those plus or minuses in front of it. All right, so let's do some more examples. I'll just do kind of 1 or 2 from each row. All right. Now, let's look at example 4. So example 4, here's my question. Do I go ahead and take the square root, or do I have to do something first? I got to divide by 6. So treat it like you're solving just a regular 2-step equation. You got to get the x by itself first. Same thing here. You got to get the x squared by itself first before you can take a square root. So I'm going to divide both sides by 6. So x squared is equal to 8. Now I can take that square root. So x is equal to plus or minus the square root of 8. And then, of course, we need to simplify that radical. So if I simplify the square root of 8, what are two numbers where one is a perfect square that I can break 8 down into? 4 and 2. So this is the same thing as the square root of 4 times the square root of 2. So x is equal to plus or minus what? 2 square root 2. All right. So remember, I want your answers in simplified radical form. So if the radical can simplify, make sure you simplify it down. All right. Let's look at example 8. So example 8, if we're thinking sad mep, what's the first thing I gotta do? Add the 20. We gotta get rid of the subtraction first. That goes away. 3x squared is equal to 20. Then what do? Divide by 3. So x squared is equal to 20 over 3. Then I can take my square root. So x would equal plus or minus the square root of 20 over 3. However, what did I say we can do to simplify that? Well, I can't multiply anything yet until I rewrite it as what? I have to rewrite it as square root of 20 over square root of 3 first. Then I can multiply the top and the bottom by the square root of 3. So you cannot multiply anything in this form. You got to get it to that form first. So this would be the square root of 60 over the over just positive 3. Now, 60 I can probably break down. So what are two factors of 60 where one of them is a perfect square? 4 and 15. So I can rewrite this as square root of 4 times the square root of 15. So x would be equal to plus or minus, what's the square root of 4? 2 times the square root of 15 over 3. Can I simplify anything else? Can 15 break down to two numbers where one is a perfect square? No. Can I simplify 2 over 3 any? No. So we're done. Any questions on that one? All right, let's try another one. So, example 11. So, look at it carefully. What do you think I'm going to do first? Take that square root. All right. Now, when I take the square root, I'm going to have x minus 3 is equal to plus or minus the square root of 12. Now, we can simplify the square root of 12. So let's go ahead and do that. So square root of 12, what can I break it down to? 4 and 3. So this would be square root of 4 times the square root of 3, which is what? 2 square root of 3. Plus or minus 2 square root of 3. And then what's my last step? Add a 3 to both sides. Now, you will not add this 3 to that 2. You will not add this 3 to that 3 under the radical. Because remember, you cannot combine radicals unless they have the same radical next to each other. So the only way we can rewrite this is x is equal to plus or minus 2 square root of 3 plus 3. And that's all we can do. We're done. Because remember, if we broke this apart, this would be 2 square root of 3 plus 3 and negative 2 square root of 3 plus 3. So we still have two answers. But that's just the shorthand to write as plus minus. Any questions on that? All right, one last thing I want to get through. All right, what's the glaring issue here? Not the 1.
The 16. The 8.
The 8x. So that b value. We can really only take a square root if the b value doesn't exist, or if a singular x doesn't exist. However, what did we learn that we can do? to get rid of a b value and rewrite it, say, as something all squared equals something. Nope. Think about it carefully. Think back to the last unit that we did. What does that look like? What form does that look like? No. What form? So remember the three forms of quadratics? What form does that look like? That does not look like factor form. That looks like vertex form. All right. What form is this? Standard form. Do we know how to go from vertex to standard form and vice versa? So if I go from standard form to vertex form, how do I do it? What's the method? What's the pain in the butt method that we did a lot of practice on? What's it called? Remember the algebra tiles? Completing the square. So, another way you can solve quadratics is by completing the square. So, the way you can do this is that you first subtract your c value over. So, x squared minus 8x, leave a space, is equal to negative 15. Now, who remembers what goes in that space right there? B over 2 all squared. Good. So whatever your b value is, that's negative 8 over 2. Square it. So that'll be negative 4 squared, which is positive 16. So we could have just went ahead and factored it, but I still want to go through the process. But remember, whatever I add to one side, I got to do the other. So I would add the 16 as well over here. So this will give me basically what I started off with again, but I just want to make sure you guys know the process. All right. Then I would factor this perfect square trinomial. Who remembers my trick for factoring it without having to do AC method?
Wait, isn't it the exact same thing?
It is. So we could have just skipped the whole completing the square step and just went ahead and factored that. But I just wanted to remind you of the steps because you'll see it again where you have to do it. All right. So you would do square root of the first, square root of the last term, and separate those two numbers by the sign of the second. So this would be x minus 4 all squared equals 1. Well, now we can solve that by taking a square root. What do we do? Take the square root of both sides. So I get x minus 4 is equal to plus or minus 1. Then what do? Add the 4. So this would be x is equal to plus or minus 1 plus 4. And then what's my last step? So break it apart. So we have positive 1 plus 4, negative 1 plus 4. So what are my two answers? 5 and 3. So x would equal the set of 3 and 5. Now, you could have, so like Sutton said, this kind of gave us, when we did the completing the square process, it gave us what we originally started with. But you know what? I want to remind you guys because guess what we're going to do tomorrow? Solving by completing the square. All right. So I just wanted to see you guys get a feel for it. All right. And we'll continue it tomorrow. All right. So here's what we're going to do. It's 9 o'clock. So what I want you guys to do now is I want you guys to clear your desk of everything except for something to write with, and you can have a calculator out as well.